This is Honors Algebra 2 Pre-Calculus. We're in Chapter 6/Partial Fractions of Pre-Calc, but we're actually doing Section 2.7 in the book. This is the only part of Chapter 2 that we do in the Pre-Calc book, since we cover everything else from the Pre-Calc Chapter 2 when we do Algebra 2 in the first half of the year. So this topic is partial fraction decomposition. The goal in doing this is to take a single fraction and express it as the sum of multiple fractions. The reason why we do this is that someday when you get to BC Calc, which is College Calc 2 or Calc 3, depending on the school you go to, this will be one of the only ways, or in some cases the only way, to solve certain issues, and specifically to integrate certain integrands. So what we're going to do is, in this first video, we're going to delve a little bit into the setup of how you do partial fraction decomposition, just setting it up, okay? Which in and of itself is a fairly lengthy explanation, and then I think you'll find it's more accessible as we start to practice these things. So when we do partial fraction decomposition, so let's start, okay, so here's the idea. So let's do some steps, okay? Step 1, you're going to fully factor your denominator. Okay, and that's going to be important, and I'm going to walk through these steps again with an example in a sec. So fully factor the denominator. Step 2, you're gonna set up your new fractions as follows. Okay, so A, linear divisors. So, or a linear factor, right? So, linear divisor or a linear factor gets a constant numerator. In fact, the underlying information here is that actually the numerator is always just going to be 1 degree lower than what the denominator is. So if the factor is linear, which is a degree 1, then the top has to be constant, which would be degree 0. But along that same logic, quadratic factors get a linear numerator. And what I mean by a linear numerator, and I'll make this clear, what I mean by constant numerator and linear numerator is a linear numerator might be something like bx plus c, and a constant numerator would just be a number like a, okay? And then the third rule is that repeat factors get one fraction for every power up to their degree. All right, and again, that kind of sounds like gibberish right now, but I'm going to walk you through what I mean by that. So over here, I'm just going to show you an example of what I mean by this, okay? So when I say a linear factor gets a constant numerator, for example, if my factor was, let's say, an x plus 7, then I would put an a on top of an x plus 7, because a is a constant, and I have a linear divisor, right? So see how this is linear, right? This is my linear factor. And this is my unknown constant, right? I have to give it a letter because it's not something I know. I know it's a constant value, I just don't know what constant, okay? Quadratic factors get linear numerators. So for example, if I had as a factor x squared plus 1, which is a quadratic that doesn't factor, then the top would have to be something like bx plus c. So again, this is a quadratic factor, right? Quadratic factor. And then I have to make an unknown linear numerator, right? So this is unknown linear numerator, bx plus c, okay? And what I mean by repeat factors, right? What I mean by that is, let's pretend that I have, let's say that in my denominator, right, as an example, I have an x plus 1 to the third. Well, x plus 1 by itself is a linear factor, but there are 3 of them. So I'm going to need an a on top of an x plus 1, plus a b on top of an x plus 1 quantity squared, plus a c on top of an x plus 1 quantity cubed. Again, the reason the tops are all constant is because the factor itself is linear, right? The x plus 1 is linear. It's a linear factor, but it happens 3 times. So I'm going to need one fraction for each power up to that cube. So now I used a, b, and c. If these were all in the same problem, there's a reason I picked A here because it was the first one I did. I picked B and C because I had already used A. If these were all in the same problem, I would have chosen 3 letters that were not A, B, and C, right? So I probably would have done D, E, and F. Okay, so that's the basics of how we set this up. Okay, so that's just the setup, right? This is the steps for setting this thing up only. You're not really going to see any things that don't occur in this this sort of list of things, a linear factor, a quadratic, or a repeat factor. So we're going to start there, and in the next video, we're going to actually set up something, but not go the whole way through the decomposition. We're just going to do a couple of examples of setting up the decomposition without actually finishing it out. What I mean by finishing it out is we would find the numerical values for A, B, C, D, E, and F. I would not give you a problem with this many unknowns, though. That's a lot. So this is just a rough sample.